You're good. Go ahead.
All right. Well, thank you, everyone. Thanks, Tracy. Thanks for joining today. Thanks for having us. We're excited to be talking about Phoenix Air Systems today, who Holden reps us throughout the state of Georgia. So really excited to talk to you and hopefully educate you on what hygienic air handlers are, what they do, what problems they solve. This is a pretty unknown territory for a lot of people, so hopefully you can pick things up. Feel free to type in any questions like Tracy said. We'd love to answer as many questions as you guys have, so feel free to fire away. I'm Brian Kuntz, sales manager in the East for Specified Air System or Solutions. So Phoenix Air Systems is a brand of specified air solutions. We operate and manufacture out of Grand Rapids, Michigan, along with other sibling brands in Weatherite, like Tracy had just mentioned, Rapid Engineering, and Bonanza, which are all air handlers more in the industrial and commercial space. So happy to be here today. Before we get too deep into it, we also have Mark Burrows, who is our Director of Technical Sales. Mark has 40 plus years of experience within this industry. So Mark's job is pretty much to walk through facilities, identify problems, and put together solutions for those problems. So feel free to direct any questions his way. And Kevin O'Rourke, who is our Director of of Sales, not technical sales, for Specified Air Solutions. So he's the support behind the scenes as well. So with that, Tracy, I believe you might have a poll, but does anyone here have any kind of experience with hygienic air handlers? Feel free to either answer the poll question or raise your hand. Just want to kind of gauge the audience here.
Yeah, so we're running the poll now. We have a couple,
Perfect.
three,
Okay.
four.
So a handful of people, which is
Yep.
fine. So of those, can anyone or does anyone know what the most mission critical goal of a hygienic air handler is? You can type it in the chat. You can, I don't know if you can speak up, but you can start by typing in the chat, I guess.
Sorry, we block everybody from talking.
No, you're good. Understandable.
You can hop in the chat if you want to. Yeah, we got four on the poll. So
Excellent. Excellent. I'm just trying to pull it up, Tracy. See what the answers are. Feel free to read them out loud. I can't get there too quick.
can you read?
So,
Go
the
ahead and
number
read your
one,
question.
I'll answer it
Read.
for you. Get ahead here.
Yeah.
Mission critical goal of our hygienic air handlers is to protect the food. The quality and safe food brand reputation is the utmost priority for these food and beverage processing facilities, right? We're all consumers on this call today. You'd be lying if you said you weren't. So we all want to eat safe food, and quite frankly, anytime there's the words of Salmonella, E. coli, Listeria that are brought up within these facilities. It's a bad day, week, month, year, could be even business ending in some extreme cases. So obviously there's a lot that goes into it. The quality of your air is certainly part of that. A lot of people get focused on the in-room sanitation, which is certainly important. But air quality is sometimes forgotten about. And that's something that, touches the product, it touches the employees, it touches all the equipment in your room. And if you don't have adequate indoor air quality, you are certainly putting your facility at risk. So that's where we come in. We want to make sure that these food processing facilities can fluctuate back and forth between process mode and sanitation mode, or process shifts and sanitation shifts, very easily and hopefully seamlessly. That is one of the biggest troubles and problems that we see time and time again at these various sites that we walk. So that's what we'll be talking about today. A lot can go into that. So here's a quick snapshot of what you might see on a rooftop, a common configuration. We actually just added a few more units at this particular site. This is a ready-to-eat facility. So when we say the term ready to eat, that's anything you can take from your store shelf, rip open the piece of film, throw in your microwave and eat, or just eat directly off the shelf, right? So anything that's ready to eat certainly should have some sort of hygienic air handling equipment, providing the air to those process rooms, and likely even be in HEPA filtration, which we'll get into a little bit later here today. So the markets we serve, again, anything that's food and beverage related, but just to call out a few specific markets, we're looking at poultry, pork, beef, the proteins, dairy, cheese, potatoes, fruit, seafood, ready to eat, like we'd mentioned, any grocery warehousing spaces, or really anything that's just more food sensitive. So not only do we serve the various aspects of the food and beverage manufacturing facilities, but we also provide the solutions across other parts of the rooftop. and throughout your facility. So for storage areas or maybe unoccupied zones, we have some more industrial grade air handlers available for you to use that don't have the full wash down hygienic capabilities like our hygienic handlers do. So just a few examples of recently satisfied customers that you might be familiar with. Customer support throughout the entirety of the process is super important to us here at Phoenix Air Systems. Obviously the upfront process from evaluating sites to identifying what the problems are and putting together solutions for those problems, but also throughout the order and the installation process. At Phoenix Air Systems, we include our startup commissioning within the base price of each quote because we want to ensure that our piece of equipment is operating optimally. And then going a little bit further post-install, we also include free on-site support. Mark, myself, or maybe even someone else in our service group will go on site 4, 6, 8, 10, 12 months after the unit's been installed, just to do a quick evaluation. We can do a training at that point with the end user, maybe even the contractor if they're still around, to make sure that everybody fully understands how to operate our piece of equipment. This can be a large investment for some of these larger projects, and we want to make sure that these customers understand how to handle our piece of equipment. So with protecting the quality of the air in these facilities obviously the goals listed here on the left side of the screen we talked about a little bit with maintaining the quality of food, but we also want to maximize production capabilities, which I'll talk about a little bit more in a few slides here. And then with that, we can also enhance some worker comfort. And with those goals come challenges. So some key challenges that we typically face are maintaining room temperatures at or below 50 degrees, ideally 45 degrees, especially in your proteins. Reason being, any environment that is above 50 degrees is prone to promote the growth of bacteria. So ideally, we do want to see most of these rooms under 50 degrees. Not all of them do fall in that category, but some of the critical ones certainly do. And then along with that is managing the moisture in the room. So we're talking relative humidity, we're talking dew point, which we'll touch on a little bit here today when Mark starts to talk about the technical side of things. We want to establish the baseline of airflow throughout the entire facility. So not just the room or the process room that we're talking about, but we want to see what's going on in the entirety of these facilities and make sure that we have the understanding of airflow versus product flow, which you'll see here on the next slide. And then, of course, with that comes making sure the proper filtration is in place on our units and all the other componentry for that matter. We understand that every project brings different obstacles, whether it's application-based or maybe it's even budget-based. So we want to make sure that we're accommodating all aspects of the project for these customers. So diving into the 5 key characteristics of our units, I mentioned room pressurization, and this is super critical for those that have ever been on a kill floor or a harvest room or evisceration. I mean, these are very, very dirty environments. And if that's butted next to a process room, you absolutely need to make sure that your process room is properly pressurized. If it's negatively pressurized and you're sucking in the atmosphere from that kill floor, you are certainly at risk to see exposure to contamination. So ideally, kind of seeing, let me pull up my laser here. The product flow will typically go from the kill floor to your process room to your packaging room and then eventually out the door, right? So inversely related, you really want your airflow. So you want to expel that air outward from your process and packaging rooms to adjacent nearby spaces that may be dirty. So you definitely don't want to be, you don't want to have the direction going from the kill floor to your process room. So with that, the other thing we like to do is get on site because we can get a full picture of what's going on at these facilities. You can see in the examples here above, it's pretty common to see doors are propped open or, large garage doors are always open because forklift traffic and whatnot. So it's good for us to get a full understanding of what's going on so that we can put the appropriate solutions in place. So air filtration, most commonly you're going to see pre and final filters on our units. So our pre's are going to be typically MERV 8, MERV 10 range, and your final filters are going to be MERV 14 onwards up to your HEPA filters, MERV 16 and up, depending on the application. Rarely, but occasionally we will see the need for an intermediate filter. Sometimes those pop up during bakery applications where the environment's full of flour. You kind of need an extra catcher's mitt, if you will, to collect the dust in the airstream. Room conditioning. So this is super critical, especially as it relates to dew point issues. You can see on the picture here shown There's tiny speckles on the ceiling here. What's not shown is this is directly over open product. So as you might guess, every one of these droplets of water could possibly contain bacteria, right? And all it takes is one droplet of water to land on open product, and you could have an outbreak of some sort. So we want to make sure we eliminate the possibility of this happening, which really gets into psychrometrics that Mark's going to talk a little bit about today, and how we avoid that. Air change rate. This is really critical, especially when bouncing between sanitation and process shifts. So for those that don't know, during a normal process period, we were talking about 45-degree rooms, right? At night or whenever their sanitation comes into play, those process rooms, shut down for the day. Sanitation shifts will come in with 140-degree water temperatures to spray down the in-room equipment, floors, walls, ceilings, pretty much everything in those rooms. And when you do that, you're certainly going to create a fog bank, a lot of moisture that you need to evacuate from the room. So with our units, we have process mode and we have sanitation mode to align with those process shifts and those sanitation shifts. So half an hour or an hour before sanitation comes in, you will switch our unit to cleanup mode, and our unit will go from commonly a mixed air unit, which is taking 5 or 10% outside air and being mixed with 90-95% return air to filter, cool, and heat that air back to the room. During sanitation, our unit converts to 100% outside makeup air. So, for example, if this is a 50,000 CFM unit, 50,000 CFM is coming in from outside air, 50,000 CFM is being pumped into the room, and then 50,000 CFM is being evacuated out of that room. We typically like to see an air change every 3 minutes to make sure we're grabbing as much moisture and evacuating it out of the space through either our integrated exhaust fans that you can see shown in this picture or through remote exhaust fans. Either way, you want to get that air out of these rooms. So that's definitely a big piece to making sure that production can come back in the morning and get started right away. A lot of these facilities have USDA inspectors. If they come into these facilities, and you'll see some pictures here soon, and they have extreme fog banks, they will not allow this facility to go into production. So there is a cost associated with not being able to run during production. We call this at Specified Air and Phoenix Air Systems our return on air, right? So if we can mitigate and eliminate altogether any downtime, we're helping put money back in the customer's pocket. And then, of course, this overall sanitary design. In a perfect world, we'd love to see stainless steel, everything. That's the most hygienic you can get. That being said, we also understand that budget reasons may not ask for that. So we do have some other lesser hygienic options that do help from a budgetary standpoint, but ideally, you're looking at stainless steel dampers, interior liners, certainly drain pans, which are standard throughout the entirety of our unit. So it's not just post coil like you might see with some manufacturers. We do put stainless steel drain pans through the entire unit. That way you can walk in with a pressure washer and hose down the equipment rather easily, and it evacuates that through the drains that you see shown here on the bottom, and then off your rooftop. So that definitely ties into whatever the customer's preventative maintenance schedule is, but we at least help in making sure you can evacuate the water and all the cleaning chemicals that might go into these units. Also shown, you can see the pre-filter bank here. This shows a belt-driven blower. We do offer direct drive fans as well. That's more common. One less thing to maintain as far as replacing the belt and whatnot. And then you can see our cooling coils. Typically like to see stainless steel tube, aluminum fin, but we do offer an array depending on what refrigerant you are working with. So we can support DX, we can support flooded, we can support recirculated systems from ammonia to the Freon and whatever flavor of the month is hot to CO2 and really anything in between. There's nothing that we have not quoted to date. And then, of course, you have your final filters, which will connect to your supply ductwork that will provide air to your process rooms. We also offer 3- and 4-way diffuser heads if you guys need those for discharge head options. So quick case study here, just talking about that return on air I mentioned. This picture, quite frankly, doesn't even do it justice, this before picture in the top. A lot of these facilities, Mark and I, we've been in sanitation shifts at 3 a.m. and you can't even see your hand in front of your face. I mean, they're really that bad. So then you're talking about, employee safety, let alone, starting up for production in 3 or 4 hours in some extreme cases. So this particular facility was doing upwards of $1 million of product a day. They had multiple hours of downtime because of the conditions seen in the before picture here. So it was starting to impact their profitability. Of course, we want to see what's shown here in the after picture, just a clear, somewhat mostly moist-free environment. You will have some moisture, obviously, as you're pumping in water, but by the time production shifts start, you should be fairly dry and good to go and not impacting your production time. So extreme cases, we talked with one particular customer that had about 2 million, they did about 2 million pounds of meat a day out the door. At $7 or $8 dollars a pound, you can certainly see what the impact of 1, maybe even 2 hours of downtime can have on that company's profitability. So we want to make sure we provide that return of air and making sure their conditions are optimal and they can keep running their production shifts. So these next few slides I want to show are just examples of things that, are currently in place because, customer had to figure out short-term solutions. But fortunately, there are solutions out there like our Phoenix Air Systems hygienic air handlers that will eliminate these from having to happen. So there are 3 things going on in this picture that, I tip my cap to the customer for doing what they need to, for a quick short-term solution. But these tarps are in place to catch dripping water from the ceiling. And this takes time to put up tarps, take them down, clean them, and whatnot. The other thing going on, they put a red sock, for lack of better words, around their diffuser, rather than really addressing the root cause issue, which in this case happened to be high face velocity off these diffusers, was wicking moisture from the diffuser heads and over open product. So they put the sock, the old term, what is it? Put a sock in it. They took that in a literal sense, and they did that for their short-term solution, which is probably fine. But given the nature of where these are located, I'm sure that they are not replacing them very often. You're probably just creating another avenue for bacteria to grow and then expel outwards. Another thing that just shouldn't be needed. And then lastly, it's hard to tell. There's a person here with a 20-foot mop or squeegee trying to get the moisture off the ceiling of this particular room. I'm sure they didn't hire this person specifically for that job, and they probably could be spending their time doing something more productive. So again, just something that's really not needed if you have the right pieces of equipment in place and the right sized equipment.
Hey, Brian, before you switch, let me jump in real quick.
Sure. Take it away, Mark.
So also, when you guys are going to your plant sites, okay, it's critical on this to notice how much exposed metal we have, right? Corrugated metal, all the structural beams and whatnot. What a great place to catch or to have the formation of condensation, right? So there's 3 types of ceilings that we walk into. In a perfect world, it would be the false or the 4-inch IMP panel ceiling, which is great. Those are what we'd like to see. In this case, this was never intended to be a production room. It was more of a warehouse. So basically, they moved all their production stuff in here and tried to keep this at 45 degrees. And every single night, when they go into sanitation, that hot water hits the floor, that vapor rises up. It's all about dew points, right? It's going to condense wherever it can on that ceiling. And there are lots of opportunities for bad things to happen on that ceiling. So keep an eye on those ceilings. Is it a false IMP ceiling? Is it going to be a steel structure like this? Even more intriguing is when you walk into these facilities and you'll see the concrete I-beams, if you will. Those are really challenging in the fact that concrete's been at 42 degrees all day long. Take the hot water hose, you can imagine the rainforest that you're going to encounter in those. So as you evaluate these projects, always be cognizant of not only the size of the room, but keep in mind what that ceiling looks like so you know what you're dealing with. Makes a huge impact.
Yep. Great point, Mark. Other reasons we like to get on site just to evaluate the current situation at these facilities. You can see some exposed ammonia piping in the room. Ideally, you want to pipe ammonia piping outside of the room or ideally outside of the building altogether. These are being routed to ceiling hung evaporators that you can see on the far left here. We'll talk about how our equipment can tie into that in a little bit. But just another reason why we like to get on site and understand the full picture. Another before and after, this is another ceiling hung evaporator, which can take care of the room load during these process cycles. The issue that comes is during sanitation, right? So you don't have any way of evacuating and making up the air in these spaces. You're certainly going to have a condition like what's shown on the right. So we have makeup air, which is truly 100% outside makeup air units that operate during both production and sanitation shifts. They pair up nicely with ceiling hung evaporators to add that room pressurization piece. that's missing when the ceiling hung evaporators are taking care of the room load.
Before you switch, Brian, so everyone's clear on this. The photograph on the left is probably pre-op, probably 5 o'clock in the morning. There's nothing wrong with the ceiling hung evaporators. A lot of plants use them. There is no fresh air in this room whatsoever. When they go into sanitation mode and they take the hot water hose 140, 150 degrees off that boiler, and that room's been 42 degrees, again, you get this instant vapor that travels up. Typically speaking, on these evaporators in the room, they don't turn those off, they leave those on, right? So if the suction's 25, let's say 30-degree suction, and that unit is still left running, yes, it's going to condense a lot of moisture on the cooling coil. The problem is once you cross the saturation curve, you will literally see a fog bank on the discharge of that. That's super saturated air. So not only do you have the issue of the fogging effect with the hot water on the cold floor vaporizing, you also have it coming right off the evaporator. And a lot of plants like this, now you're talking OSHA problems, safety issues, and all the rest of that. So to Brian's point, a simple makeup air unit would probably definitely solve their problem in this scenario.
Yep. Last slide of kind of things that we commonly see, or hopefully not too common, but one question we typically ask on this slide, in these upper three pictures here I'm circling, we always ask, how old do you think this unit is? Typically we get answers from 5 years to 10 years. This is 4 months after install. Now, granted, this is at a breeding facility, so the nature of the application is a little bit harsher. It's just one more reason why we like to get on site after the install so that we can make sure the proper education and understanding is in place at the end user level, so that they're, number one, taking care of their unit as they should be, incorporating it into their preventative maintenance schedule, but also making sure the sequence of operations running as it was originally designed. If we need to make design changes at that time, obviously that's a good time to do that. But we definitely don't want to see conditions like what are shown in these pictures. And then really from there, it's kind of a cascade effect. Sometimes we'll see missing filters. Air takes the path of least resistance, right? So the rest of these filters probably aren't doing a whole lot. Then you start to impact your face velocity within the air handler and out into your room. Sometimes we see filters removed altogether. So you can imagine what that does to the air quality in the room. The last particular one, we had a few issues with our service team on burner troubleshooting. So Mark and I happened to get on site, walk up. First thing we see is a remote exhaust fan. As we're asking, hey, is this remote exhaust fan in operation? They were during sanitation during this picture. We see steam start coming out of the remote exhaust fan, and you can see it's directly under the intake hood of our air handling unit. So it's just another reason why we like to get on site. We can also make recommendations outside of just the pure solution of our air handling unit, as far as overall hygienics go in different configurations. So with that, I'm going to hand it over to Mark. He's going to talk a little bit more about product offerings and the solutions from a technical standpoint, more in depth, as well as some of the different performances that we provide along with our quoting process. So Mark, feel free to take it away.
Okay, my name is Mark Burrows. I am the technical sales director. I've been doing this for a long time. These aren't necessarily things you pick out of a catalog. It's really helpful if we can get to the job site and evaluate what's going on there. Just because there's a problem in one room, you got to dig a bit further and see what the rest of the plant airflow looks like. It's all tied together. So as far as product offerings, anywhere from 3,000 CFM on the low side, as much as 100,000 CFM for full-blown units. They are, in fact, manufactured in Grand Rapids, Michigan. Mixed air units, that's probably 80% of what we sell. It's got 2 modes, and this is important. Unlike a commercial type unit, definitely 2 specific modes of operation. They're very different. The process mode, or I call the money shot, that's where the end user is producing whatever he's producing. We take 5 to 10% of the total CFM, and that's used for positive pressure in that room. We don't want to see any doorways being sucked in the process room. We want to make sure we have a slight positive pressure so this good, clean, cooled air is going out in the hallway, not letting any of that bad air in. That bad air, by the way, in the hallway consists of 2 things that can go wrong for us. It could be full of bacteria. It also could be at the wrong dew point. So if your room's 45 degrees and you're bringing in 65-degree hallway, that air will condense wherever it can inside the building. So again, 5 to 10% outside air is usually sufficient. Keep in mind, on 45-degree process rooms, it's 10 tons per 1,000 CFM. So as you elevate the outside air, while it's important to control it, you don't want to bring yourself in too much outside air because it's really expensive back to the engine room. So when they're done doing process modes, keep in mind, no one really has 8 hours for sanitation. It's all about throughput. So you're probably going to see 2 shifts at 10 hours apiece. Most plants are lucky to have 4 hours to pull that room down. They're sanitizing everything, and then they're going to start back up in 4 hours from the time they start to get the room down to temperature, and certainly all the condensation off the ceiling. That's where that mixed air unit with the flip of a switch goes from a little bit of outside air to all outside air. We want to basically flush the room out. When we talk about the 3-minute air change, the simple math is this. Take your square footage of the room, multiply it by the ceiling height. Most of these rooms will be 20 foot high. If you can divide that total cubic feet by a 3-minute air change, that's usually suitable for 2 things. It gets you a good selection for the airflow required to make sure you can make room temperature. On the other side of the fence, it's also a great number, the 3-minute air change, to get those rooms dried out quickly. If someone says they need a desiccant unit, that would be a red flag, and let's do a little bit more digging on why a desiccant unit's really required. The typical 45-degree process room probably runs between 80–85% relative humidity. If someone said to you they had a 45-degree process room, they want to keep it at 50% relative humidity, that's going to beg the question, why does it need to be in that situation? Desiccant units have their place, but again, a lot of the things that we see from the photographs you saw before on dirty units, imagine a very slow-moving desiccant wheel taking out moisture. If they don't take care of that equipment, you can imagine what that slow-moving desiccant wheel would look like 2 years down the road. So we do supply those. We're always going to ask the question from a solution point of view, what is the end game for the customer? What's the temperature? Most of the time, if you ask your customer, what's the relative humidity? They probably can't answer that. They just want to run continually and not be shut down. So again, 45-degree rooms, 80–85% relative humidity. Some of the slides we showed before where you have ceiling hung units which are doing fine and you have an issue with positive pressure, we can certainly provide a small makeup air unit, which is all outside air with cooling and heating, putting in a certain temperature or a predictable temperature all the time. If it's a case where there's a sanitation problem, where that room's a big fog bank, by all means, then we'll use that 3-minute air change. Just take a makeup air unit, no cooling required. In the summertime, we're bringing raw ambient air in to flush the room out. If we're bringing 50,000 CFM in, we're taking that out as well. If it's cold outside, of course, we don't want to bring in 0-degree air into a cleanup situation. We'll heat the air to 80–85 degrees and then discharge that in the room. And again, that dry air will then pick up the moisture and take it right out to atmosphere.
Yep. One thing I want to add, Mark, just while we're on this picture, Mark mentioned these are pretty custom. Just examples of that. You can see the custom snorkel hoods installed on these units shown. You can also see the integrated exhaust fans are turned at a 90-degree angle because the units are in parallel. Obviously, we don't want to be blowing moist sanitation air directly into the intake hood of the unit that's next door. So again, just a good example of these are custom and are designed to be fit in your unique applications.
And just before you flip the switch on this, we did a job once at a different company where I worked. Not only is it critical where these units are placed as far as air distribution in the plant, this job was in Manitoba. It was -40 without the wind chill. They had units very close like this. When they went in the sanitation cycle, out of the discharge, and typically those exhaust fans are perpendicular to the unit. You can see these are canted 45 degrees, so the air does not smash into the next unit. Well, imagine when it's -40 degrees outside and you've got discharge air at 75 degrees full of moisture. It basically made that next unit an igloo. So you have to be very cognizant of what the air discharge looks like both in the room and the discharge up on top of the roof as well.
Yep.
Mixed air units, again, these are required for pressurization. And again, they are going to replace all the ceiling hung units. There'll be no evaporators or ceiling hung units in this space. All of that load is going to be taken care of on the unit itself. In the picture to the right, We can do all kinds of things. This happens to be a bottom return. So it goes up and then into the unit. We can do bottom discharge. We can do end. The sky's the limit as far as what that looks like. 2 modes of operation again, process and cleanup, 5 to 10% outside airs for process. Cleanup mode, 100%. The norm for these are the MERV 8 or a 30% pre-filter, which is the 2-inch throwaway. If it's basically a cut-up room or on the raw side, you'd be okay with a MERV 14 or 15 at a 95% filter. Again, if you're doing RTE applications, you might want to think in terms of HEPA filters, which are 99.997 effective on a 0.3 micron. As a standard control package, it's going to be Allen Bradley Compact Logics. Every time we quote a job, we like to really get down in the weeds and kind of explain what's happening inside the confines of that unit. So in this example, this is a mixed air unit. Whenever there is a change of color, something's happening inside that unit. So Brian, let's go to the bottom right-hand corner and we're going to show the room size. This is 60 feet wide by 125. And then right below the yellow, Brian, you'll see the room size summarizes at 7,500 square feet with a typical 20-foot high ceiling. The room volume is 150,000 cubic feet. That's what we're working with. Go up to the top, Brian. Of this unit, which is a 50,000 CFM unit, which is just to the right of the cooling, left of the cooling coil, 50,000 CFM. Okay, of that, 5% of that air comes from the outside. This happens to be 95 dry bulb, 78 wet bulb. We can talk about the RH and dew points, not a big deal for this discussion. What is a big deal is the return air. So if I have 50,000 CFM of total CFM and 5% outside air, that means I'm bringing back 47,500 back to the unit. Notice its temperature. This is typical, right? 45-degree dry bulb at an 85% relative humidity. Now we'll talk about the wet bulb at 42.9. The critical takeaway from this slide is the dew point of the room is 40.8 degrees. That means whatever we discharge into that space better be below that dew point, or what's going to happen? It's going to condense moisture on the ceiling. So here's the air in the cooling coil is comprised of 3 things. It's the blue outside air. It's the yellow return air. Typically on these, we like to use what we call a blow-through configuration. What does that mean? That means that the motor is before the cooling coil. A 50 horsepower motor in this example will have 12.5 tons all by itself. You're going to raise that temperature, the blended temperature of the outside air and the return air, 2.5 to 3 degrees. So the air on the cooling coil is 50.2 and 46.7. Here's the air off the cooling coil. At a plus 30 suction, this is probably as good as it gets if we want to have a wet coil and not go through defrost. We're leaving at 33.4, 33.3 dry bulb, wet bulb. Is that pretty moist air? Yep, it's 99.0% relative humidity. We are certainly not going to absorb any moisture in the room with this airstream. Is this a safe configuration to deliver to the room? Well, look at the dew point. That's 33.4 degree on the discharge dew point versus the room at 40.8. That is definitely what we see all day long as a safe configuration. Under these conditions, you won't see any vapor trails coming off the supply diffuser into the room, let alone condensation. If we just choose to put a reheat coil in this, we're going to heat the air from 33.4 dry bulb up to 35. It's very, very small. The point of this discussion is look what happens to the RH, the relative humidity. It goes from 99% down to 89.6. So we change the RH ever so slightly. You never ever with reheat change the dew point, and you certainly don't take any grains of moisture out. So then we'll evaluate this back to the compressor. Left-hand side, what this unit will have total load is 121.5 tons. That is back to the engine room or back to the air-cooled condenser, whatever the case might be. We talked before about 10 tons per 1,000 CFM. We've got 2,500 CFM of outside air. In this case, it's 24.2 tons that we have to account for. That is the outside air load. The motor load, again, at a 50 horsepower is 12.5 tons. This is easy math, right? A 50,000 CFM unit has a 50 horsepower. A 10,000 CFM has a 10 horsepower. It's basically a straight line ratio is all it is. Bottom line for the room, as if to say we were going to hang ceiling hung units, would be about 84.8 tons. Okay, that's the load. And what that means is we get about 88.5 square foot per ton. The safe range is typically 100 square foot per ton. And all we're doing, you look at your room size at 7,500 divided by what's available for the room. In this case, 84.8, and you're left with 88.5 square foot per ton. Typical stuff, a little bit on the conservative side, but it would certainly work. And then look at that air change down below at a 3-minute air change. Very, very safe configuration. Typical on these with a wet coil, so we don't frost the coil, is a 12-row, 6 fins per inch. This is important. A lot of commercial guys might look at this and say, let's get as much heat transfer as we can. That heat transfer doesn't really, you get the most bang for your buck on the secondary, which is the fin stock. We never, ever would like to go more than tighter than 6 fins per inch. Okay. Number one, those are going to be really thin fins. We like to use a 0.014, which is a pretty stout fin, versus sometimes guys will use a 0.007. Very thin, and you can fold the fins right over. Plus the fact you need to clean these coils as well. So it's really hard to clean an 8 or 10 fins per inch coil. Our standard for a 45-degree room would be a 12-row, 6 fins per inch. The suction, again, is at 30. The sensible heat ratio is 64% of that's going to be sensible. The other 36% is going to be of latent work. That's where we're taking moisture out of the airstream. And other details, not that it matters for this discussion, we can actually tell the client exactly how much moisture we're taking out, GPMs we're condensing at a given time. Any job that we do, whether it's a small job or a large job, you're going to see the same sort of evaluation as far as the psychometrics. So again, the process mode, 5% outside air. We're going through the pre-filter, which is a 2-inch pre-filter. The heating is off. The cooling coil is definitely active, and we're going through the filtration. If you're taking notes on this, on a wet coil, we don't like to go more than 600 feet per minute on the cooling coil. If we go above that, the fear is we're going to blow water off into the airstream. What is directly downstream of the cooling coil is the filtration scenario. Those filters like to run about 550 to no more than 600 feet as well, feet per minute. So think in terms of your cooling coil and your filters at or about the same velocity going through them. We showed a photograph before of a unit that had some filters missing. What happens when you take the static pressure away from the filters? It's about a 0.25-inch water column on a pre-filter, which is the 2-inch throwaway. It's as much as 0.75 to maybe 1 inch on a final filter. If a customer chooses to take those filters out, what happens to the static pressure? Static pressure goes down, CFM goes up. That's exactly why in the one photograph that we showed, they had that sock material on the diffuser. Why? The filters are missing. Now this unit is delivering a lot more air at a higher face velocity. Therefore, there's issues with that. So just keep that in mind. It's critical that these have all the filters in place so we can manage the airflow going into these plants. Sanitation mode, that's exactly the same unit. We're just going to flip this from process to 100% makeup air. Cooling coil is typically locked out in sanitation. We're going to take the raw ambient air. If it's summertime, we're going to flush that into the room and then take all this moisture out to atmosphere. If it's cold outside, typically we'll supply a direct fire burner. It's going to heat up to maybe 80, 85 degree discharge. That warm air is then put in the room. You can imagine how much moisture is absorbed in that sponge-like environment. Again, wicking the air off the ceiling and taking it right out to atmosphere.
And we can also offer indirect fired burners as well, just to note that.
So as far as what the units look like, these are pretty simple. We like to sell units in chunks of where we can, 10,000 CFM. There's a 15,000, 20, 30,000, so on and so forth. That's typically in like 9 units that we'll use in our wheelhouse. We can also go through charts and it would say if your room is, let's see here. Let's go about the bottom, Brian. Let's take a a 5,000 square foot room, in this case, 4,900. Here's the easy math on this. 20-foot high ceiling, you would be into a pH 40 with the 3.8 minute air change or 3-minute air change. The units are basically the same. We talked about the static pressure, whether it's a 3,000 CFM unit or a 100,000 CFM unit. As long as we're using the same pre-filters, cooling coils, and final filters, that static pressure is about 0.27 through the unit with another 3/4 of external static pressure. So that air is extremely predictable on and off the coils, provided the face velocities are always the same. The bigger units, anything over a 20,000 CFM unit, would be a 3-piece application. So these are going to ship in 3 module sections, which would then be bolted together at the job site. Makeup air units, again, this is required for 2 reasons: 100% outside air for positive pressure during process cycles. And it can also certainly be used for that of the cleanup cycle. If a client's got a very foggy application, certainly look at that 3-minute air change, and we can offer a relatively simple makeup air unit. No cooling, just raw ambient air. If it's cold outside, the burner would fire off. Again, since you're bringing in outside air, you'd have to have at least a MERV 8 pre-filter. A lot of guys like to use a MERV 14 in the discharge just to make sure whatever they do bring in is certainly cleaner than that of the room itself. Same control strategy with the Allen Bradley control platform. Makeup air is kind of the same deal. This is basically just a 3,000 CFM. Brian, the bottom left-hand corner, even though there's no return air, we certainly want to note what the conditions of the room are. In this case, they're 45 degrees. There's that 85% relative humidity, and we've got a dew point, again, of 40.8 that this room has. Again, keep in mind there's ceiling hung units pulling the heat out. We just need makeup air for this. So we take the yellow at the outside air at 95.80. Why is there a color change? Because we've got the motor heat. We take the air from 95 degrees up to 98, so there's that 3-degree rise. The air off the cooling coil in this case is 37.2, 37.1. Notice again the relative humidity, 99.1. So now we're talking worker comfort. Nobody wants 37-degree air to blow down their back. In this case, we take a simple reheat coil. We've already got the air down below the dew point. This is just worker comfort. We take the air from 37.2 up to 45 degrees. And look what happens to the relative humidity. That change from 37.2 heating up to 45 degrees, we change the RH from 99.1 to 73.3. Notice again, you don't change the dew point, and you certainly don't take any grains of moisture out. This is nothing more than we're going to overcool the air, take the moisture out, and then heat the air back up for worker comfort. So plan view, of course, whether it's, again, 3,000 CFM or it's a 100,000 CFM, it doesn't matter. Fresh air intake, mixing then with the return air going through a pre-filter bank. Typically, now this has the blow-through configuration, so we're going to heat the air up. Then the air off of that situation goes into the cooling coil. The air off the cooling coil would then either hit a reheat coil or go directly into the final filter. What we're typically doing on the final filters is a face velocity, again, of about 550 to 600 on the high end. Most contractors would design for maybe 1,500 to 2,000 feet per minute through his ductwork. So you will definitely see a transition from the large opening that we have of 108 by 96 down to some much smaller configuration for the ductwork. For the most part, these are going to be installed on structural steel. There are situations where, to save cost, people would put these on roof curbs. We're not big fans of these on roof curbs when the room is probably 40 or below. Warmer rooms are one thing, but we got to be really careful that we don't have any condensation problems beneath that unit through the curb. So you got to be really careful on that. So again, for sake of argument, we probably put these up on structural steel.
Yep. The other thing I wanted to call out, Mark, we do offer UVC lights post-coil as well, if those are needed. Other bells and whistles, smoke detectors, ammonia detectors, leak detectors, interior light packages with a receptacle at the control panel, just to name a few things, catwalks, platforms, surge drums for flooded systems, we can all provide you with. So we try and provide as much as we possibly can for each air handling unit.
And keep in mind, at the plant, these are fully tested. We certainly can't put a refrigerant through it, but we can certainly check all the IO and whatnot. We'll fire off the burners to make sure at the plant they're working properly, such that when we go to the job site, the startup tech would go out, start these up. He's not troubleshooting. He's basically, the shop's already done that. His job is pretty easy, basically just making sure the wiring is correct from the field wiring, and then he'll definitely test the unit, full-blown test at the job site. If we want to, we talked before about the 50-degree room temperatures. That's kind of a USDA mandate. If you're above that, you're going to have to go through something called the mid-shift cleanup. The colder we can keep the room, the more it's going to retard the growth of bacteria. So a lot of process areas now want to run at 40, maybe 36 degrees. We talked before about a 12-row, 6 fins per inch coil for a wet coil. This is something that we'll call a sequential defrost, where we are going to intentionally hit this with a 20-degree suction. Does that mean we're going to frost the coil? Absolutely, but we want to control that. So on the left-hand side of the dashed line, you see CC 1, 2, and 3. Those are nothing more than 3 individual stack coils, each with its own drain pan. The days of old, people would actually put face and bypass dampers by the coils, or they try to put hot gas and all this other stuff. The problem with all that is, number one, dampers are mechanical. They tend to fail if they're not taken care of. If one was to put hot gas through these coils, the end result is I'm going to have warm air on one of the coils converging with the cold air off the others. Therefore, we might have condensation problems. So what you're going to see on this, where you see the CC1 in yellow, we're going to intentionally defrost that coil on the fly. A little bit of frost is okay, but if we bridge the fins with ice, you're never going to defrost the coil. This fan is running continually at 23,000 CFM. When it's time to go and defrost via a timer, we still want liquid in all 3 coils all the time. All we do on the top coil, we're still feeding it with cold liquid. We change the dual pressure suction regulator to 34 degrees or 50 pounds in the case of ammonia. I can still catch the air at 45 degrees on the entering side of the coil. I can warm this coil up from the inside out, so to speak. We can defrost these coils in about 10 minutes. So the condensate that comes off of that top coil, it's got its own drain pan. I don't want that condensate to hit coils 2 and 3. There's a drain that goes right to the bottom of the unit. When this thing is done defrosting, the top one turns blue, so it's active or it's at the colder temperature. The second coil then drops out in its defrost, and it just repeats this all day long. Even if we're in defrost, look at the discharge dew point. The discharge dew point is 29.1 degrees. Is that a safe condition? Well, the dew point of the return air is what? 36 degrees. So we can take these anywhere probably on the low side to 35 degrees. We probably can't get much colder than that, but we're seeing more and more facilities. Their QA folks like the fact that the employees certainly don't like it, but as far as retarding bacteria, they like to run these colder and colder. If you're going to do that, you're going to need something like this. If one says they want a desiccant, this is the sky's the limit on desiccants, right? How much moisture do you want to pull out? How many grains, so on and so forth? How much air is going to bypass the wheel? This is quite the math equation, but again, the point is we can solve those problems as well. As far as solving the problem, I would like to suggest that not only do we offer the desiccant, can we do this with simple mechanical cooling and reheat coils? Can we achieve the same thing? Again, the desiccants certainly have their place, but in the harsh environments that we play in, you see what happens to these units where people don't change filters. What you definitely do not want is that desiccant wheel. This was a big deal, by the way, 15, 20 years ago in a lot of poultry plants. Every poultry plant that I've been to has a condensation problem. So what do? They would rent desiccant units. They proved their point. They work. They bought a big desiccant situation. And then the plant guy is like, how do I clean this? How do I replace the wheel? So again, nothing against desiccants. You need to have a firm handle on what the application is and is it really required. So the nice thing is we can offer the solution with the desiccant, or can we do something a bit more user-friendly as far as simple mechanical cooling and reheat.
All right. Well, thank you, Mark. I'm going to take over for the PM series. We mentioned obviously the focus is on these process rooms and making sure that they have adequate air. But we can also take care of the rest of the facility as well. So we have our PM and our PCM series, commercial and industrial grade makeup air units that can supply adequate air quality to storage areas or unoccupied zones or even office areas. So it's, we can really cover the entire rooftop, even outside of the process room areas. So with these, you can see the common styles. We have makeup air, 100% outside makeup air, our air management or AM style, also called 80/20 units, taking that mixed air application that Mark just gave you the lowdown on, variable air volume and fixed recirculated styles as well. As far as configurations go, pretty much anything and everything. It's, horizontal to vertical, from indoor suspended, upright indoor, pretty much you name it, we can support it. So want to make you guys all aware of this as well. And these units can go up to 150,000 CFM, so a little bit larger CFM range than 100,000 CFM that our hygienics can support. Warehousing spaces, that's the other thing. Probably not so much in the cold storage area. I would say, the comfort cooling ranges from, what Mark was talking about, 30 degrees on upwards. Cooling can be added to these as well. RFQ information, not going to touch on this too much because Holden does a good job of getting all the information we need to put solutions together. Wanted to show a quick snapshot of some of our other sanitary design. You can see the stainless steel dampers and liners here, and the stainless steel drain pans throughout. Our production team really does a good job and takes a white glove approach. For example, they'll roll cardboard out on these stainless steel drain pans to make sure that we don't ding up and scratch the stainless steel and compromise it so that it ends up promoting rust in the long term. So we really do take care of these units, and we go the extra mile to make sure that they're in first class shape. What's all said and done, a lot of these projects, whether they're greenfield, large renovation projects, or even replacement projects, can be pretty time consuming for consulting firms, contractors, everybody that's trying to plan and design this work. We really just ask that, hey, we can take the air handling piece off your hands. Of course, you're going to be with us along the entire way of the project. We need your approvals anyways. So we'll make sure to set up meetings to walk you through all the solutions that we're putting together and make sure that we get your sign off. But that's one piece of the project that we can certainly handle for you. You can see, these show 2 twin blowers. We do offer some redundancy as well. Motor removal systems if we need to, so that in the long term, if they need to remove a large motor, they have the ability to within the unit. Then our manufacturing excellence, kind of talking about the white glove approach. Mark mentioned fully inspected and tested prior to shipping, and then retested once they're installed on site. So we want to make sure that our units leave the facility and show up on site just like they left our facility, right? So we make sure we shrink wrap all of our units and secure them during transport. And make sure that we minimize any disruption and downtime at the plant. So we want to have easy installation. You can see, there's a crane here lifting up each section of the unit, typically in order. I've seen these get installed within half a day, a single unit, for example. So they can be fairly quick depending on who's doing the install. So when it's all said and done, we want to make sure our end users are remaining profitable. We talk about keeping production up and running. USDA is not a concern because there's no environment condition issues in these facilities. We can also prevent some employee turnover with comfort cooling, and just keeping that facility, up and running as much as possible and maximizing their efficiency. Predictability, that's the checkup that we do during and after install and offer that training and evaluation. Again, we want to make sure that the customer understands what they've invested in and how they operate our piece of equipment. And then dependability. We have very good lead times right now. We're sitting at 16 to 18 week lead times, which is extremely competitive versus some of our competitors. And then, we offer the redundant motors if needed. We really just want to be your trusted air solution provider at the end of the day. So I think we do an excellent job of serving our customers from consulting firms, contractors, and end users. We want to make sure we cover all bases of the project to make sure that everybody's educated. So that's really all that we had to share with you today. I did want to leave it open. I know we have a few minutes here for any questions. I haven't had a chance to look at the chat box, but I wanted to open it up. Tracy, feel free to add anything else, but see if we have any questions.